Hello and welcome to another episode of Study Session for AP Physics 1. In this video we'll be covering circuits, and sorry I haven't posted in a while. I've been a bit busy with some competitions at school, so that's been kind of like my priority. But now I have a bit of time before my next one, so I've got some time to make some study session videos. So this video will be covering direct current circuits. In circuits, they're tested on the AP Physics 1 exam, right? But they're not like, it's one of those things that you don't have to understand really any other of the concepts that you cover in physics to understand circuits. Like, even if you understood none of the rest of AP Physics 1, you could still understand circuits. You could still learn how to do them. So with that being said, let's get into some problems. Okay, first problem says, for an ohmic conductor, doubling the voltage without changing the resistance will cause the current to, okay, so we know that our voltage is being multiplied, so V2 equals 2V1. And it wants to know if the resistance is constant, so R2 equals R1. What happens to the current? So I2 equals XI1. So the equation that relates voltage, resistance, and current is voltage equals your current, I, times your resistance, R. And in this case, if our voltage doubles, so we've got 2V1 equals I times, or I2 times, it's R2 equals R1, so it's just R1. We get that I2 equals 2V1 over R1. And if we solve for I1, so we have V1 equals I1 times R1. We get I1 equals V1 over R1. And seeing we have a coefficient of 2 here, we can find that the current, in fact, increases by a factor of 2. So if we double the voltage without changing the resistance, our current will also double. All right, on to the next problem. I just need to get my eraser, get that nice and big. And I actually believe in my last video, I accidentally said pi is infinitely large. I misspoke there. I meant to say like infinite. I said infinitely large, but I meant to say infinitely long. So it's infinitely large in terms of like the number of digits, because it repeats on to infinity. But I accidentally said infinitely large, and I figured that could probably be misinterpreted as, oh, well, pi. That was a really bad pi. Let me go back and do that. Oops. Pi equals infinity, but it does not. It does not equal infinity. It's like 3.14 and a lot of other digits. But yeah, that's what I meant whenever I said that. Okay, on to the next problem. Okay, if a 60-watt light bulb, so 60 watts, and watts are a unit of power, okay? So this is equal to your power. Okay, operates at a voltage of 120 volts equals voltage. What is the resistance of the bulb? So your power equals your current I times your voltage V. But if you look at this equation, we're trying to solve for the resistance. You notice, well, there's no R here. How the heck are we going to solve for resistance? So what we have to do is some formula substitution. So we know that V equals IR. And if we know that V equals IR, we can solve for I in terms of V and R, and we get I equals V over R. So we can then say that your power equals your voltage times your voltage over your resistance, because you've got your voltage multiplied by your current in terms of voltage and resistance. So you get that your power equals V squared over R. Okay, so now if we just solve, we get that 60 equals 120 squared over R, and R for your resistance. So if we multiply across by R and divide by 60, we get 120 squared, which is 14400, divided by 60 is your resistance, which ends up being 240 ohms. 240 ohms, if you solve that equation right there. All right, on to the next problem. If my eraser would pull out. Okay, a battery whose EMF. Okay, so EMF is given by this symbol, and it's equal to the voltage. It's in volts. So the EMF is 40 volts, equals 40 volts. And it has an internal resistance of 5 ohms. So resistance internal equals 5 ohms. It's connected to a 15 ohm resistor. 15 ohm resistor R, and it wants to know what will the voltage drop across R be. So if we quickly draw out the circuit, right, we've got our battery here, and then at some point along the circuit we've got that resistor, and then it comes all the way back to the battery, and this is 15 ohms. And your voltage drop across your battery, or not voltage drop, your resistance across your battery is 5 ohms, and it is a 40 volt battery. So what we first have to do is we have to solve for our total resistance to solve for our total current. So what we have to do is these resistors are in series, so it means that we can add them to solve for their total resistance. So our total resistance is 15 ohms plus 5 ohms equals 20 ohms, right? It's okay, so now we have our total resistance. So now that we have our total resistance, we can solve for our total current using the voltage. So voltage, which is 40, equals your resistance, which is 20 ohms, times your current. So I'm going to divide by the 20 ohms for resistance, and that means that your current equals 2 amps. So now we have our current, which is 2 amps, which is running through the circuit, and we know that whole 2 amps, it's only following this one branch. It's going to be running across that entire resistor. So we want to know the voltage drop across that resistor, right? So we can solve for the voltage drop using V equals IR for that resistor. So it equals your current, which is 2 amps, times your resistance, which is 15 ohms, which equals a total voltage drop across that resistor of 30 volts. And that would be how you do that one. Okay, on to the next problem. Okay, this one is going to be a lot of drawing, but it will be a good practice problem. And this will be the last one that we do today. So let me draw out this circuit real quick. You got point A. Apologies for taking a bit to draw this out. It's just a big circuit. I keep pressing the button on my writing tool, and it's making it stop writing. And point B. And this is 12 ohms. This is 4 ohms. This is 3 ohms. And this is 3 ohms. Okay. So it wants to know the total resistance between A and B. So basically we're going to have to combine all these resistors because, they're all between A and B. So let's first start by adding our 4 ohm and our 12 ohm resistor. So these resistors, they're in parallel, as you can see. And how we have to add those up then to solve for the total resistance of this parallel branch is 1 over 12 plus 1 over 4 equals 1 over R total. So our sum of the resistance for this branch right here, I'll go ahead and quickly calculate that. So we've got 12 to the negative first plus 4 to the negative first and all that taken to the negative first. That would be a 3 ohm total. And anytime you have two resistors in parallel, you will end up with a lower resistance. Okay, so now we've got 3 ohms for that total branch right there, and that's in series with that 3 ohms. So you can just add those together. So that's 3 plus 3 equals 6 ohms. So the total resistance of this upper part is 6 ohms. So I'm just going to go ahead and cross out everything else I don't need because I've already solved it. So right now it's only one resistor up there. If we look, okay, so now we've got a 3 ohm resistor up here and a 6 ohm resistor up here and a 3 ohm resistor down here. So how are we going to add these? We're going to use the parallel equation because they're in parallel. So what we have to do is 1 over 6 plus 1 over 3 equals 1 over R total. So R total equals 6 to the negative first plus 3 to the negative first, and all that raised to the negative first, is 2 ohms for your total resistance, which is your answer. So there's 2 ohms of resistance between point A and point B. Alright, well, hopefully you guys enjoyed this video. If you need any more help, be sure to visit my website, studysession.org, and I will be happy to answer any questions you have. And if you have any suggestions for any more types of videos or what to cover, just leave it in the comments below, and I will see you in the next video.